Good night for from here and joining in the conference. And I'm really glad and happy to be joining this conference. And from my point of view, I will talk about just the smart building and energy efficiency. So from my title, these things. And this work, the student in my group, there's a few members I will talk about later. Just from the title, we'll talk about the smart building and energy efficiency. Maybe these things will be work in a big scenario like smart cities or smart countries. So maybe in very big way, I mean big scenario. So these things will be worked by the machine learning. That's my discussion of the talk today. And my team, like Professor Giancarlo Fortino and this, another two professors, like he's our lab director, and Antonio Guerreri and Rafael Gravina is also my supervisor, and me just working as a PhD student in this project. About this outline, I will talk about these research topics and overview of this machine learning stuffs, how it's work, various machine learning stuffs, and futures aspects from my discussions. Just from general understanding of the smart building. As an example, like smart building, what do you mean? What's the definition of the smart building? In the literature, exactly, there is no exact definition of a smart building or smart cities. But I can give you some scenario as an example, like the home or like cities that are going through some sensors, maybe the controlling stuffs through the internet. That's we call be the smart building. And this smart building will be handled by machine learning staffs, maybe the controlling the analysis staffs. So this phenomenon we can try to say the smart building, and we can define as a smart building or smart cities. And general understanding also, like how we feel like smart building and thermal comfort. So in the room, will I feel comfort or yeah, am I feel comfort or am I feel like cold or hot? Like these things we can define as a thermal comforts. So in the building, like I'm walking, so like in the room, maybe I'm just watching the television. That's time the comfort level a bit different. And also maybe if I'm in the room, like in the office, so that time I need a different comfortables, as well as the like various age people, like my grandfather, my kids, they are not asking for this similar type or requirement for this comfort level. So depend on the various comfort levels. So in this point, if you asking just the thermal comforts and as well as the energy efficiency, like this your lights, your air conditions, lots of stuff. So if you want to both together, thermal comforts, I mean in a room, and as well as the energy efficiency, these things a bit complex if you want to handle these both stuffs. And these all these things, like in the office, my home, my schools, my college, and my everything's to energy efficiency and management these stuffs, thermal comforts. This we can say like energy efficiency management systems. In a definition, this smart building and recap. If we want to comforts and we want to do it by machine learnings, then we have to recap something. We need some knowledge and very specifically. All the machine learnings, supervised, unsupervised, and self-supervised, we have need to know. Also, the various kinds of sensors, how it would be designed. Not so much deep knowledge, but you have to know which sensor, how it's work. As an example, like occupancy or the door sensors, how it's work, what kinds of variety, what kinds of difference, maybe the temperature, indoor, outdoor. So there is a varieties of sensors. So we have to know about the sensor. Also the the external factors, the weather I try to manage, and user feedback, like various kinds of age peoples live in this house, maybe the university or college. So their feedback also important. Just I'm just reviewing this work. So I already explained the thermal comforts. So how our energy efficiency, how we can do this? Maybe as an example, we can do it by air conditions, controlling, maybe the light controlling. If we say like the hot water, cold water management systems, there is a lots of way, plenty of way. Just if you're interested, going through, there is a lots of work has been done. It still need to be worked. So why we're doing this research, it's also really important to be like, the providing thermal comforts. If we provide a thermal comforts, so the work efficiency will be more higher. As an example, like if you are in a good place or good rooms, good environments, your work efficiency maybe 60% increase, if I'm remember this. And also, energy is the most vital issues all over the world. So if we use the more energy, we produce a more carbon dioxide. And you know about this carbon dioxide, how harmful for us and all over the world. So this is a lots of stuffs. The motivation of this work, just we are going through lots of stuffs, and try to say it's very important because inside of the room, maybe we are passing 80 or 90% time. So other stuff, we are also going through this. There is a lot of discussion to be need, but our certain time, I am moving forward. And the inside of the rooms, if you provide a thermal comforts, and also if you provide energy efficiency, you must need to be consideration these steps. As an example, the temperature is a most crucial part. Humidity is also important part in the room, like the level of moisture or dryness. It's really, really important. Also the air quality, the like how your HVAC, I mean the air condition is working, and the occupants feedback. I just a few minutes ago I said. So it's really important to occupants feedback and take actions. And the human behavior, it's most difficult to handle stuff like maybe the someone's just the 10 years boys, their human behavior, like my grandfather, like he's 90 years old, so their human behavior is different. So thinking about these kinds of condition handling and combining both stuffs a bit complex, but it's possible. And going through like there is lots of way like a machine learning application has been used in a smart building. As an example, if I say you see this just a picture slide, so if I want to talk take a lot of time, just you can overlook. And if you need anything to know, just try to send an email. I will share the slide with you. And I already talked a bit thermal comfort and energy efficiency through the machine learning. So we can go a bit like, there are lots of work we can study it and summarize in our work. This is like some papers to say supervised learning. If I say just the one model, two models, even though the one perspective, like someone consideration only into temperature, someone consideration just uh, only outdoor temperatures or air humidity. So it's depend on lots of way. And the overview, like the environment, if you want to think the humans just here summarize, supervise, and unsupervised lots of machine learning models. So just here as in this picture as an example, how the machine learning parts work in this smart building. As an example, like how I collected data. For example, this picture in the first step, I tried to show you some scenario. As an example, like hot water, air conditions, car lighting, televisions, or like the people's, the occupancy, the how many people are in the room. So that's also matter in the sense that data preparations, like experiments, and the model on application, the step by step how it's work, also explain this. So this is just I talk a bit supervised and unsupervised. This is gonna be also lots of work here. So lots of work. I try to read maybe some work in RN. I told you IAQ, the indoor air qualities. Some work occupancy predictions. Lots of work has been done in this domain, honestly, and also the lots of algorithm has been done. Let's come to the another discussion. It's unsupervised learning. Um, Self-supervised learning, you can say that reinforcement learning. There are lots of work has been done. It still need to be lots of work. So the reinforcement learning, there is maybe it's very familiar with nowadays. So it's lots of people are working on the RL. So the agent will be decided. We are giving some instructions. Through the instruction, we are not giving the guiding, but some through the instruction, like the some rules, he will work and learn, and we are not giving any specifically suggestions, but from the he will learn by himself. There's and that means the we are giving this, and he'll learn or she'll be learn. I mean, the agent will be learn and take a decision based on this. So most of this work, reinforcement learning, there is a lots of the reinforcement learning has been worked, has been used. Lots of work has been done in this way, and maybe these things use some of the point of view. Also, you need to be thermal turn on the switch off, less energy uses. But you have to provide also the thermal comforts. I mean, the comfort in your workplace. If you are in room, if you are in the schools, if you are college, if you are in shop, if you're in the market, doesn't matter. But providing both, it's a complex. These things more suitable for reinforcement learning to learn agents and decide some recent work. As an example, if I say this privacy concern and predictions, as an example, like if you want to thermal comforts, and also if you want to energy efficiency along with the data privacy. So that's very vital issues and discussion points of view. So this need to be considerations. Maybe further learning or transformer learning will be help, like maybe decentralized. I'm sorry, decentralized approach will be helpful to like data privacy concerns. And in this domain, from a bit my discussions, should be lots of work need to do. Maybe from my point of view, it's a very general word. If you see here, but if I want to like explain one by one, it's take more time. As an example, privacy concern and issues I just talked with about a few minutes ago, and interaction with the third one, interaction with the broader energy ecosystems. Like if I want to just think about this, it's nothing. I'm not talking about the one building or one smart homes. I'm talking about this all over the scenario. So maybe 4 5 cities, 4 5 countries. So it will be a bigger scenario. So one ecosystem, as an example, Saudi Arabia's conditions and the European condition is not same. So our Asian and European conditions. So this is the inter like this all over this ecosystem making in a one place. It's like complex stuff, but it's need to be lots of work and combine indoor and outdoor temperature. Like there is a lots of things. As an example, if I say just the COVID-19 times, what's going on. So that time that all of the people are inside there. So that time, how do you handle providing thermal comfort and energy efficiency? All the people inside of the room. So lots of things need to be considerations in this way. And future research will be in lots of weird things. So just maybe the hybrid reinforcement learning, maybe the human factor and consumer behavior, mostly focusing on this, and also maybe the security privacy concerns. So from our work, from my discussions, I just summarize the very recent work and how machine learning and energy efficiency work in a smart building maybe should be usable any other places. Maybe it's smart cities, it's smart market, it's smart hospital, whatever is it. So application field will be just a different. Though my work, this work I presented in a one conference, what I discussed, but like I'm getting right now, I'm working and I got some good results, and we are submitted some conferences and planning to some works to journal very soon. So this is just as an example. I try to show this. Maybe the first picture I try to show our one approach, like we just give this and another approach, the second picture, just explainable AI. So about this work I can't explain more here because it's working. We are working right now, it's still this. So that's it about my presentations. Have any, and if you want to ask any questions, write me on my email or visit my GitHub repository or just text me here. Do you have any questions?
Thank you so much, sir. Anyone, if you have any question, please ask.
Someone, Noman Ahmed. Yeah, please. Oh, maybe there's no question. So, yeah,
Yeah,
from my side, thank you everybody to join our like conference, and I'm really gladful to present my work. And if you have any questions, just let me know through my email, and maybe see you coming here. And thank you, NMBI, for your organizing this online seminar. And yeah, I'm really happy. Thank you, guys.